Hello everyone and welcome to our channel Quaint. Today's topic of discussion is electric fields and forces. When you rub a balloon on your hair, in that case what happens? There is a transfer of electrons, and since there is a transfer of electrons, so electric field builds up, and that's why when you take the balloon to a wall, then in that case it sticks to the wall. Again, in case of lightning, an electric field builds up between the clouds and the ground, and that's why there is a massive discharge which is known as lightning. So these things are known to you. Again, in case of capacitors, charged plates are used in case of capacitors to use electrical energy. There also electric field is used to store electrical energy in capacitors. Okay. So what exactly is an electric field? Say there is, for example, there is a charged object. So around that charged object, a vector field is created by the presence of that charged object. So what happens if you place another charge in that area or in that field, then that charged object feels force due to the first one. The force may be attraction or may be repulsion in nature. It depends on whether the charges are of opposite sign or same sign. If they are of same sign, then in that case repulsion occurs. And if they are of opposite signs, then in that case attraction occurs. So these things are known to you. But what is an electric field? Meaning of that, it's like just gravitational field. Okay, similarity is there. You can compare that way also. And what is the range of this electric field? That depends. Mathematically, if you use Coulomb's law, Coulomb's law, force of attraction is equal to K into product of the charges divided by the square of the distance. So if you use this formula to analyze the problem, what is the range of electric field for a given charged object, in that case mathematically this goes up to infinity. But practically there is a limitation. And if the distance is small, so in that case the field strength is more. So how this field strength is measured, calculated? Means electric field strength. It is force per unit charge. That means, say there is an object which has charge. Means there is a charged object. Okay. And due to that charged object, electric field builds up. So in that electric field, if you put another charged object, what is the charge of that object? Unit charge is there. Then, and also the sign is what? Positive. So positive unit charge if you place, then the force felt by that, or the force experienced by that positive unit charge, is known as the field strength. That means mathematically how it is calculated? It is calculated by using, you are calculating the electric field strength of a given charged object. So force experienced by a charged object divided by the charge of that object, that is known as electric field strength. So unit of force is what? It is Newton, and unit of charge is Coulomb. Therefore, unit of electric field strength is Newton per Coulomb. Then using Coulomb's law, you can calculate electric field strength for a point charge. According to Coulomb, what is the Coulomb's law? It is F. It is represented as F is equal to K into product of the charges divided by square of the distance between them. Then what is the electric field strength? Then in that case, this is the force. So force divided by the charged object. Okay. So say we are going to calculate electric field strength of the charge Q1. Then in that case, you need to divide that force by Q2, another charge which was placed in the electric field. So F by Qt is how much? It is FQ1 divided by, KQ1 divided by R square. K is Coulomb's constant, which is equal to 8.99 into 10 to the power 9 Newton square meter per Coulomb square. Okay, so KQ1 divided by R square. So formula for electric field strength is written as just simply KQ by R square. Okay, that means if distance increases, R square is there, so if distance increases, in that case electric field strength decreases, and vice versa. So this was all about electric fields and forces. Okay, and electric field is no doubt a vector quantity. It has magnitude as well as direction. Okay, and how these are measured? You know, electric field lines are used. Scientists use actually electric field lines, okay, to represent these things, electric field. And you know that direction is, convention is this, like the electric field lines point toward the negative charges and point away from the positive charges. That is the direction. That way direction is determined. Means actually that is the convention followed by the scientists. And you know that if electric field strength is stronger, in that case density of the electric field lines are more. And one more thing, electric field lines cannot cross each other, because if they cross, then at the point of intersection you will get two different directions of the electric field, and that is not possible. Two different directions at a point is not possible. It should have only one direction. That means electric field lines cannot cross each other. And if you talk about applications, so many applications are there. You are using a touch screen mobile phone, smartphone. Touch screen is touch. So here, in that case, when you touch, actually your touch is detected by using electric field strength by your smartphone. Again, in case of medical science, okay, pacemakers, electrotherapy, MRI, everywhere electric fields are used. Again, in case of particle accelerators, particles are accelerated using electric fields. So many applications are there, okay. You cannot count the number of applications where electric field is used for different technologies. Anyway, so this was all about today's topic. And one more thing, scientists are making a research in the field whether without using any wire, means wireless transmission of electricity, can we harness electric fields using wireless technology? Okay. Anyway, so this was all about today's topic, and this is the end of this video. Thank you. Thank you for watching this video.